Okay, this is the first videos for chapter 8, 8.1, 8.2, which we talk about counting principle, permutation, and combinations. And this semester we try to simplify the content for you. So the first things we want to talk about is the fundamental counting principle. So if you can perform a series of tasks, the first one you can do it A different ways, second one you can do it B different ways, and third one you can do it C different ways. Then all tasks can be done in the way of A times B times C. So let's look at some examples together. The first one say if you have 3 shirts and 2 pair of pants, how many shirts and pants outfits can you have? So this one, they want you to list them out. So if they don't want you to list them out, it's a little bit quicker. You can say you have 3 shirts and then 2 pair of pants, right? So all you need to do is multiply them together and then you will get 6 outfits. So that's pretty simple. But they want you to list them out. So let's assign something to each one. You can assign color, but I'm gonna just say shirt number 1, shirt number 2, shirt number 3. Pen is using another system, maybe pen A, pens B, okay? So if I want to list them out, I can use a tree diagram. So I can label this as I have shirt and pants. So shirts, I have 3 of them, 1, 2, 3, and each shirt can pair with the 2 different pair of pants. So A, B, A, B, A, B, right? So I can have shirt number 1 pair with pen 8, shirt number 1 pair with pen B, shirt number 2 pair with pen 8, shirt number 2 pair with pen B, shirt number 3 pair with pen 8, shirt number 3 pair with pen B. So totally I still have 6 outfits, right? So are we okay? So this is one of the example. I will give you the question files on eCampus. Alright, the second questions, when you're ready. Second question say, how many outcomes are there if you flip 3 coins? List them out. So let's try that. This one also they want you to list them out. Number 2, you're gonna flip 3 coins, and then I need to list all the outcome, right? So I know each time I'm gonna have 2 different outcome, head and tails. So I'm gonna label this like coin 1, coin 2, coin 3, right? Okay, so the first one I can have head and tail. I probably need to leave some room between them so I can branch them out with a tree diagram, right? And the second coin can have head or tail, and then each of those results, the last one can also have head, tail, head, tail, head, tail, head, tail, right? So I have 2 different outcome times another 2 different outcome times the other 2 different outcome. Totally I should have 8 outcomes, right? This is the total. And if you really want to list them, so this part we are using a tree diagram. If I really want to list them, the first one would be what? Head, head, head. Okay. Second one would be head, head, tail. And then head, tail, head. And then head, tail, 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 okay, and then tail, head, head, and tail, head, tail, and tail, tail, head, and then tail, 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 right? So you can list them out also. So that would be the counting method. So these are not probability, because probability, your answer should be between 0 and 1, right? This is just counting how many outcomes you have. So some of the time we can use that as your sample space. That would be possible. All right, let's look at number 3. Number 3 say you have a locker combination that using 5 digits for the lock combination basing on different condition. The first one, you can use any number, any order, and then the second one, no 0 for the first number, then any number in any order. The last one say any number in any order but no repeating. So let's use a piece of paper and try to write that out. All right, so I am doing locker combinations. Let's see. Number 3, we are doing locker combination. Okay, so this is going to be a 5-digit combination. Okay, and then what are the choices? Like the choices of number, we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, right? So those are all possible number digits that we can use. And the 5-digit means 1, 2, 3, 4, 5 space for you to fill it up, right? So the first one say they want to use any digit in any order. Okay, so I have 5 space to fill. So how many choices do we have for the first space? So 3, 6, 9, 10, right? So I have 10 choices for each of the space, because we so because we have the choices of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So those are all my choices. 10 choices for the first number, because I can repeat them, right, in any order, in any digits, right? So I have another 10 choices here, another 10 choices here, another 10 choices here, another 10 choices here. Meaning if I use 0 here, I can use 0 again, or like 1, 2, 3, 4, 5, 6, 7, 8, 9. So all I need to do is just multiply all the choices together. So the answer would be, how many 0? 1, 2, 3, 4, 5. 3, 4, 5. So this many combinations. So this is 100,000 combination, right? If I have 5 space to fill with number, and I can use any number in any orders, so 100,000 combination. So that's A. How about B? B say no 0 for the first number, then any digits, any order, right? Okay, so let's see. 1, 2, 3, 4, 5. So the only restriction we have is the first one, I cannot have any 0, right? If that's the case, instead of 10 choices, now we have 9 choices. But then all the rest of them, it can be any digits, any number, right? So all of them have how many choices? 10, 10, 10, 10, right? So we multiply them together. Then we're going to have 1, 2, 3, 4 zeros, and then a 9, right? So 90,000 combinations. Are we okay? So they're not very difficult, but you do need to know what's going on a little bit. C say any digits, any order, but no repeating. So let's see. Again, we have 5 space, right? 1, 2, 3, 4, 5 for the locker combination. So if I can have any order, any digits, the first one we have 10 choices, right? 0 to 9. And then I cannot repeat, right? No repeating. Which means if I use 0 here, I can no longer use 0 here, right? So I lost one of my choice. So instead of 10, this become 9, right? And then after I use 2 of those digits, I cannot use them on the west, so I lose another choice, so this turn into 8. And then after I use 3 of them, then I lost 3 choices, so now we have 7 and then 6. So if you multiply them together, I don't know what that is, so 10 times 9 is 90, times 8 times 7 times 6 is going to be 30,240 combinations. So hopefully look at those, you will it will make sense to you and what's going on with the counting. So again, these are not probability, this is just counting how many results you have. A lot of time we will use that as the sample space, like how many possible results that we have. Okay. Alright, let's look at the next question. Where's the next question? So the next one say, how many combinations of 3-course dinner can we have? So it's going to be a 3-course dinner. If there's 4 types of appetizer, 6 types of entrees, and 5 different kind of desserts. So let's get a piece of paper. Okay, let's see. So number 4, we're going to do a 3-course dinner. Number 4. Okay, so we have 4 type of appetizers, and then we have 6 type of entrees, and then also 5 different kind of desserts. Okay, so all we need to do is what? Multiply them together to see how many combinations. What number is that? 5 times 4 is 20, and times 6 is 120. Okay, double check that's correct. So we can have 120 different combinations for the 3-course dinner, right? Alright, very good. Okay, that's the answer. Anybody have any questions? Like, contact me if you have question, okay? So that's number 4. And number 5 say you downloaded 3 movies for the weekend. Like I used to say, you rented 3 movies, and a few years ago I asked my student, do we still rent movie? And they look at me really weird and say no. Okay, so we downloaded 3 movies for the weekend. How many different order can you watch these 3 movies if you only plan to watch each one time? Okay, so let's write that down. That's number 5. So number 5, we got 3 movies. So I'm gonna just name them A, B, and C. If you have a lot of time, you can list like what are these 3 movies. So we only want to we want to know order to watch them if I only watch them one time. If only watch each once. Alright, So if we only need the order, that would be pretty quick. So I have 3 choices basically when I watch the first movie, and after that, the second slot I already watched 1, right? So now I only have 2 choices to pick from. And at the end I already watched 2, so I only have 1 more choice to do, right? So together we will have 6 different order. And if I ask you to list them out, then we are going to have 1, 2, 3, 4, 5, 6, right? So how does that work? So I can watch A movie first, and then B and C, right? Or I can watch A first and then swap these 2. Or I can watch B movie first, then let me with AC, or I can flip it CA, and then I can watch C movie first and then flip the AB or BA, right? So either way you should have 6 different orders. If you have 3 movies, and how many orders you want to have, and only want to watch each one time. I could do similar question for like you have 3 different color of flowers, and how many order can you make those flowers in front of your house. So same thing, like 3 choices down to 2 choices down to 1 choice. Alright, so those are the basic counting questions. The second topic we have for this is factorial. So this is some kind of math that you need to know. So let's look at the handouts. So factorial, the way to find them is if it's like n factorial. Factorial look like an exclamation mark, which is an exclamation mark. Basically, to find that, it would be n times n minus 1, n minus 2, etc. You multiply them until you get to 3 times 2 times 1. So if I'm doing, say, 3 factorial, that would be 3 times 2 times 1, which equal to 6. So that's an example, but you do need to know how to find factorial. Later on we will show you on the calculator, but we want you to have a little bit concept. Okay, that's factorial. So 5 factorial is going to be what? We will multiply from 5, 4, 3, 2, 1, right? So 5 times 2 is 10, this is 3 times 4 is 12, so it's 120. Can you try 4 factorial? We're going to check it in a minute. And then they ask you to simplify this. So this means 8 factorial divided by 5 factorial. So basically you have 8, 7, 6, 5, 4, 3, 2, 1, right? And the bottom you have 5, 4, 3, 2, 1. So you will end up like canceling this part, right? So sometimes people will do it like that. They say 8 times 7 times 6 times 5 factorial, and then at the bottom I have a 5 factorial, so those two will cancel. So all I need to do is 8 times 7 times 6, right? So they mean the same thing. 8 times 7 times 6 is 336, is that right? Hold on. Yeah, I was doing something different. Okay. 876 is 336. Alright, so if you can, I want you to pause your video and try number 7 and number 9, and then we can check with you real quick. So take a minute and see if you can do that. Okay, if you're ready, the next one would be just 4 times 3 times 2 times 1, right? That would be 24. Okay, how about the last one? So I don't have to list a lot of stuff, right? It's 70, 69, 68 factorial, which at the bottom I have a 68 factorial, right? So I can cancel that. So all I need to do is 70 times 69, which will be 4,830. So okay, let me add one more question for this. If you have something like this, then we are going to have this is 10, 9, 8 factorial, right? And I have an 8 factorial here, so we can cancel that. But then I also have a 3 factorial here, so what do I do? So this would be 3 times 2 times 1, right? So I can cancel 3 times 3 is 9, 2 times 5, right? So this is 5 times 3 equal to 15. Are we okay with that? Alright.